Hello and welcome. It is time for lesson 1.5. Today we're going to be talking about estimating. And we'll start here with this question. How many hairs do you think are on your head? And you might be thinking to yourself, well, how in the world would I ever know that? Right? And that's kind of the point here of this question is there's really no way that we could ever count all of the hairs on our head one at a time. But we could make an estimate, right? If we knew how many hairs were in a little chunk of our hair and then, thought about, well, how many chunks of hair are there? We could start to make an estimate. We could start to get an answer that's not the exact answer, but is somewhere close, right? And that's called an estimate. And it is a super important skill to be able to do, not just in math at school, but just in the real world in general. So here's our math message question. This says that the teachers at Burkhart were holding a contest. If the school's students read at least 20,000 books, every student would receive a free book. Here are the totals. So it shows you grade one and how many books they read, and grade two, and all of the different grade levels. Oh, go fourth grade, go. All right. What we need to figure out is, have the students read enough books, and how did you decide? So there's several different ways to think about this and figure it out. But why don't you take a moment and try to decide what you think? Have the students read enough books, and how do you know that? Well, there's a lot of ways that we could think about this. We could, take all five of those numbers and just add them up on a board or on a piece of paper, or we could use estimation. And that's what today's lesson is about. And I'm going to kind of model for you how you would use estimation to figure that out, rather than adding up every single one of these numbers, which is going to take a while and could lead to, different mistakes that we make as in terms of adding up the trying to get the exact numbers. So what I would do is I would estimate these. So I might take this number right here, this 3,574, and round that up. Okay, so that's about 4,000. This one is about 2,000. And the third grade number is about 3,000. Fourth grade has read about 7,000. And see, what I'm just doing is I'm taking what I know about rounding, right? So the three, I drew an arrow over here in my head, and I was thinking, okay, five and above, that's going to give this a shove, and that's why I put 4,000 out here. So I'm rounding each of these numbers to the thousands place in this case, based on my data. Then our fifth grade number here is 2,000. Well, that would round up though, because seven would give it a shove. So that would be 3,000. Okay. And then I can add these up. And adding these up is a whole lot easier than adding up those numbers, right? 4 plus 2 plus 3 is 9, plus 7 more is 16, plus 3 more is 19. So 19,000. So my estimate is that no, the kids did not read 20,000 books yet. Okay, and so we can save ourselves a lot of time with estimating, and it's really something that we do a lot in the real world as well. On your in your SRB, there's a page here about estimation, and you can just look on the screen, but you're welcome to get out your SRB if you'd like to look at page 82. But I'd want to read just one little section here so that you can know a little bit more about estimation. Okay. An estimate is a number that is close to the exact answer. You make estimates every day. Here's some real world examples. You estimate how long it will take you to walk or ride from one place to another, right? This is what you're doing, what your parents doing. If you're on a car trip and you say, "Mom, how long until we get there?" And mom says, "Oh, I'll be there in about 45 minutes." That's an estimate. Second one, you estimate how much money you can save by the end of the year. Maybe you're saving up to buy this big fancy thing that you want, right? And you decide, oh, if I save, you know, about $5 a month, I'll have around $50 to $60 by the end of the year. That's estimating. And the third one, you estimate how long it will take you to complete a school assignment or a chore at home. If dad says, go in there and clean your room, and you say, oh, you want to be done in about a half an hour so that you get to it, right? That when you estimate that about a half an hour, that's an estimate too, right? And so useful estimates, it says, are based on reasoning, meaning that you don't just guess, right? When mom's trying to tell you how long you have until you get left in the car, she doesn't just pick a random number out. Doesn't just say like 16 hours, right? They're based on reasoning, based on some evidence. Estimates can help you make sense of a situation or help you approximate a calculation, right? Get close to a number. So, our goal today is to estimate using different methods to come up with an answer that makes sense. And we're working with a problem solving standard here, right? To be able to, eventually attend to precision and down at the bottom here, right? Making sure that the context, that means that our answer is going to fit the situation that we're learning about. So we're going to learn 3 different ways to estimate, right? And these might be useful in different situations. And so you kind of have to determine which one you need when you're in that situation in your life. Here's our question that we're going to use to model these 3 ways. On Sunday, 463 people were at the lake. On Monday, 226 people were at the lake, and 312 were there on Tuesday. Estimate how many people in all were at the lake. So there's one of my keywords, right? In all, in this case, that's an adding problem. But it also says estimate. So if I just add up these 3 numbers and give the exact answer, well, then I haven't done the correct thing. I've come up with an answer, but not the answer to this question. So I'm going to estimate. Here's 3 ways to do it. Strategy 1 is to round all the numbers to a particular place value. This is what I did with the book's question earlier, right? If we round these numbers, we round 463, we round it to 500, we round that one to 200, and we round that one to 300, right? Just like you saw me do earlier. Then we would add those up. Strategy number 2, here's a new one. This is called front-end estimation. So we're just going to take the digit in the highest place value. That the digit in the highest place value stays the same, and everything else turns to 0. So in this kind of estimation, we would say, okay, 463, we're going to take 400 and 200 and 300. Okay, so that's front end estimation. Like I told you, there's several ways to do this. And strategy 3 is called close to estimation. We're just going to look for a number close to the original number that it's easy to work with, right? So friendly numbers, meaning like 650 is a friendly number, 800, right? Just numbers that we can add pretty well in our head. And so, in our problem for 463, well, that's pretty close to 450. This is pretty close to 225, and 312 is, close to 300. So just kind of finding a friendly number, a number that's easy to deal with in this situation, right? If we add it, then if we want to know the exact number, right, the exact number, we add up those 3 numbers. In this case, the answer was 1001. And you can see that our estimates, some of them were closer than others, and that's it. That's why you have to decide what kind of estimating you want to do based on the situation that you're in. Here's our goal. We're going to be able to estimate using different methods to come up with an answer that makes sense. So let's try one here together. Here we have Emily, me, and Eric need at least 900 popsicles for the school picnic. Emily bought 283, me brought 356, and Eric brought 411. Do they have enough popsicles? All right, so take a moment and I want you to choose. Are you going to round each one of these to the hundredths place and then add them up? Are you going to choose a friendly number, right? That close to estimation. Are you going to make this 350? Or are you going to do the front ends of these numbers, right? To use that method. So you have 3 different ways that you can estimate as you practice this problem. So take a moment and give that a try. All right, now what you're going to see under here really depends on the method that you picked. okay? And so if we're going to round each of these numbers, we would end up with this: 300 plus 400 plus, check that, that should be 400 also. And that would give us 1,200, right? Or we could do front end estimation. Find the front end estimation under there, right? Just taking the front ends of the numbers: 200, 300, and 400. Or down here, we can go close to. What are these numbers close to? 300, 350 is a pretty friendly number, 400. Okay, so there's different ways that we can estimate this. As we look at all three of these, if they need at least 900 popsicles, they are going to definitely have enough for this activity. Okay, so our estimate is actually yes, they do have enough popsicles. All right. Sometimes methods might want a more precise, that means exact estimate. And so rounding and close to estimation often get you a little closer to the real number than front end estimation, but it can be useful at times too. All right, you only have two problems today, and that's because each problem has a few parts. You're going to read the problem. You're going to you're going to estimate and then answer the question, tell how you got your answer, and then tell why you picked that strategy. Okay, and you can see there's several lines here, so we want to make sure that we describe that fully. Why did you choose the rounding one? Or why did you choose the friendly number, right? The close to, or why did you choose the front end estimation? Okay, and so you're going to describe those on that problem and this problem. All right, that is all. Our goal today is to be able to estimate using different methods to come up with an answer that makes sense. And please let me know if you need any help, and good luck.